Welcome to Module 5 of the Credit Strategies reading in Fixed Income. This is another very important module, this one. We need to know how to use our credit default swaps, our credit derivatives, to express a view about what the credit curve is going to do, and also to be able to calculate our profits and losses from using credit derivatives given a subsequent outcome. So to start off, we're going to refresh our knowledge of what a CDS is, what a credit default swap is. Of course, a credit default swap is a derivative. So it's a contract that we use when we're engaging in synthetic strategies. So we're not trading the underlying bonds themselves here. We're trading a derivative which references credit risky bonds. Okay. Through this derivative, we can increase or decrease portfolio exposure to credit risk. All right. It's very important that you keep a very keen eye on which party is increasing credit risk and which one is decreasing credit risk, okay? Because that's what's going to trip people up here. Just a brief reminder that CDSs, of course, are OTC derivatives. In other words, there's no formalized central exchange. They're traded over the counter between an investment bank and their clients, or between investment banks. And so it's a bilateral agreement. In other words, two parties agree the contract. It'll be based on the legal documentation protocols put out there by the International Swaps and Derivatives Association, like, for example, the ISDA Master Agreement that must sit between parties A and B, which sets out how they're going to do business with each other, what rules are going to apply, essentially. And yes, being an OTC derivative, there's no formal central exchange or clearinghouse, so there is going to be counterparty risk between counterparties. You know, if B suffers a loss, they need to pay that to party A. A actually suffers the counterparty risk that B can't afford to make good on those losses. So a CDS in its most simple form is just really an insurance contract. If I were to go with an insurance contract that we're all probably more familiar with, you've got a protection buyer, say car insurance. You've got a protection buyer that pays over a regular premium, makes a regular payment. The insurance premium, if you like, to a protection seller, the insurance company. Now, the protection seller is taking on board some risk, and if that risk crystallizes, if an event happens that the protection buyer is insured against, then the protection seller needs to make a payment to the protection buyer. All right, so if you just change the word car to bond, you've pretty much got CDS. You've got a protection buyer that makes a regular payment in return for protection against some credit event. Rather than a car crash, it's some sort of credit event, like an issuer files for bankruptcy, an issuer breaches a covenant, an issuer goes through a restructuring which harms bondholders, a sovereign issuer essentially claims that their debt is no longer valid. That would be called a moratorium or a repudiation. All of these are things that could hurt bondholders, and they're things that you can buy insurance against, buy protection against happening. So yes, here's the CDS here. You've got the protection buyer paying over a fixed coupon and receiving in return a payment on a specified credit event happening. Like I say, default is probably the most obvious one. So we do need to be referencing an issuer or a reference obligation. Obligation is a posh word for bond, all right, particular security. We do need to be referencing something. That thing that we're referencing is not technically part of the CDS, all right, but the CDS is referencing it. And if there's a default or a missed payment or a breach of covenant, something like that, it could be very well the case that party B has to make a payment over to party A, if that's an event that is specified in the CDS, okay? Now, which party is suffering credit risk? It's very important at this early stage to realize that credit risk is being taken on board by party B. If something bad goes on from a credit perspective, party B suffers by making a big payment. And therefore, credit risk, if you like, party B can be viewed as going long credit risk, the protection seller. Right, be careful with that, because this party over here is actually going long the CDS contract. The party buying protection is buying protection, buying the CDS contract, but they are actually shorting credit risk. Okay, be very careful with that. The risk is over here, credit risk is over here. all right, with the protection seller. You've got to be careful with fixed income just generally for inverse relationships right from the get-go, but in particular with CDSs, because the protection buyer is actually short credit risk. So it's like they're selling credit risky bonds, benefiting if credit risky bonds fall in value. This party over here is actually going long credit risk. They don't benefit if credit risky bonds fall in value. They benefit if credit risky bonds rise in value, or if there's no crystallization of any negative credit events. Maybe an easy way to bust through this is to just think in terms of spread, because after all, this fixed coupon is linked to a fair spread that should be paid. All right. There's a technical point to that which we'll cover later on, but if you can think of spreads going up, that means the cost of insurance will go up, and that means the CDS buyer, the protection buyer, wins. Okay. Think of the CDS buyer as being long the spread rather than long a bond, and you'll start to unlock how to think about these CDSs when we put them into action. Okay. Don't forget, spreads widen when credit conditions deteriorate, which is good for somebody that's short credit risk. Okay, so here's really just a basic, very basic example to make sure we've got our ducks in a row here. A manager is bullish on issuer X. Do they need protection there? Probably not. They're bearish on issuer Y. Do they need protection there? Probably yes. So you can either think of it in terms of protection. If you're bearish, you would buy protection, which is actually shorting credit risk, like selling bonds. If you're bullish on a name, you don't need protection. In fact, you might sell protection to somebody else, sell some of that insurance to somebody else, and just collect the premiums, and then there's no claim, if you like. There's no payout required. Okay, so maybe the protection side is something that works for you. You could either go through that side, probably the most useful one here. If you're bullish, you don't need protection, so sell it. No one needs protection in your view. If you're bearish, you would buy protection. Okay. And don't forget, what you do with the CDS, you do with protection. So where you're bullish on issuer X and you're selling protection, that means you'd sell a CDS and take on board credit risk. Okay, you're happy to take on board credit risk here because you're going to get paid a spread for a risk that doesn't crystallize. Party Y, buying a CDS, buying protection against something bad happening when you think it will happen. And sure enough, if conditions deteriorate and spreads widen, being long a CDS is a profitable trade. All right, now I did mention there was a technicality that we need to consider with regards to this fixed payment. The fixed payment that the protection buyer pays over to the protection seller is actually a fixed coupon, which is standardized depending on the reference name. Okay, if the reference name is investment grade, then the fixed coupon that's actually paid by the protection buyer to the protection seller is 1%. Okay, if the reference name is high yield, in other words, the second rating in B or below, investment grade, you'll remember, is the highest B rating and above. Okay, if the reference name is high yield, then actually the coupon is standardized to 5%, higher as you'd expect buying protection on a more risky name. Now, of course, that immediately begs the question, hold on a minute, is that fair? It's probably not the case that all investment grade bonds have a cost of protection of 1% and all high yield bonds have a cost of protection equal to 5%. In fact, it's pretty much impossible, right? So this isn't fair. And that's why an adjustment needs to be made at the outset of the contract. The fair payment that should be made, the fair premium that should be paid by the protection buyer to the protection seller, from party A to party B, for the protection, for the insurance, is referred to as the CDS spread. The reason why we standardize it with a fixed coupon, which is not necessarily fair, is so that contracts can be processed easily. The operations market know that, investment grade CDSs pay regularly 1% and high yield CDSs pay regularly 5% when you're thinking about what the buyer pays for the protection. It simplifies the operations. And what we need to do at the outset to settle up any difference between what's fair and what's actually paid is for there to be a one-off upfront payment. If what's fair what should be paid is greater than what's actually paid, then the buyer needs to pay more. All right, the buyer needs to make an upfront payment to the seller. Yeah, remember the fixed coupon is either 1 or 5. Let's say we've got an investment grade name and actually the fair CDS spread is 1.5%. Well, 1.5% greater than 1%. The protection buyer needs to make an extra payment, a one-off extra payment up front to the protection seller at initiation of the contract. Similarly, if the fair CDS spread for the name is less than the fixed coupon that's actually paid, the seller pays over a payment to the buyer. Okay. All right. So we do need to. So what is this upfront payment in calculation terms? How do we actually calculate this upfront payment? Well, if you think about what this difference is representing here, how much the spread is different to the fixed coupon, you're really looking at a change in spread, aren't you? If we multiply up this change in spread by the spread duration of the CDS contract, then we can estimate the price impact of this change in spread, this difference in spread. Okay, and so that's what we're doing here. All right, in the unlikely scenario that the fair CDS spread is the same as the actual fixed coupon paid, then there'll be no upfront premium, but that's not very likely all the time. In the more likely case where the CDS spread that's fair is greater than what's actually paid, then we take the difference. I think in my example it was 1.5 versus 1 for an investment grade name, and you scale up by the effective spread duration for the CDS. And that will be paid to the protection seller by the protection buyer because they're not paying enough. Yeah. Conversely, if the CDS spread is less than the fixed coupon, then actually the difference, and that is how much the CDS spread is below the fixed coupon, that needs to be paid to the protection buyer from the protection seller because the protection buyer is paying too much. They're actually paying a fixed coupon, which is more than what's fair. So they're your upfront premiums. Make sure you can calculate those. And incidentally, and not incidentally, actually, very importantly, that this upfront premium affects how the CDS is priced. The value of $1 of notional principal of the CDS is priced as 1. Okay, 1 for $1 of notional principal plus this, essentially this upfront payment that's paid to the buyer from the seller. So if you think about it, what we're doing here is we're just, if there is a payment to the buyer, this increases the CDS price. And what are we saying about a payment to the buyer? Well, in that case, the buyer is paying too much. They're actually paying too much. And if you like, the name spread is low. All right, the reference names spread is lower than what's actually being paid. So it's a quality name. Right, so if there is a payment to the protection buyer, it's a quality name. This will be positive and the bond will be trading above par or notional principal. I say the bond, the CDS contract will be trading above the notional principal. So that's why it's priced this way. This pricing mechanism is designed to maintain the inverse price spread relationship that we see in fixed income all the time. We know in fixed income generally that prices are rising when spreads are falling and vice versa. Well, if you check out this way of quoting the price, when spreads are falling, that's a negative. That means that prices will be going up. Okay? And if we trade at par, we now know what that means. If we trade at the notional principal, we know what that means. It means that turns out the fixed coupon was actually fair. If we trade above par, then what we know is that the fair CDS spread must be lower than the fixed coupon. It's a quality name. Spreads are low. If the name trades below the notional principal, we know that spreads must be high, and the name is a lesser quality name. In fact, the CDS spread must be greater than what's actually being paid. And this preserves the inverse price spread relationship that we are so familiar with in fixed income markets. Okay, let's have a look at an example of these calculations which mirrors an example in the text. So we've got here a manager purchasing protection on a high yield reference obligation. You've got a 5-year CDS contract with a CDS spread of 5.5 and effective spread duration of 4.5. Oh, this is a high yield reference obligation. It is probably worth you knowing that that means that the fixed coupon for high yield names is going to be standardized to 5. That's the thing that's standardized, and that's what's actually paid. Now, shock horror, the protection's actually worth, this is what's fair, the protection's actually worth more than that. So big picture here, let's get a big picture question in before we just start, kicking the ball into the weeds here. Is this CDS going to be trading above par, at par, or below par? Well, we've got a fair CDS spread, which is greater than the fixed coupon. Okay, so this is a risky name, isn't it? It's a bit like yield versus fixed coupon, isn't it? If we require an extra return bigger than what's being paid, then we're going to trade below par. So the price here is going to be below par, all right, below 1. When I say par, I mean it's trading at, a price which is $1 per dollar of notional principal. But I'm using that analogy of expressing notional principal as par. So calculate the upfront premium and state who it gets paid to. All right. Now, my advice, if you just try and learn formulae and there's lots of negatives that keep switching around, you're going to get it wrong. My advice is focus on the understanding, and then the sign comes from your understanding. You don't need to worry about whether it's positive or negative, or whether it's, spread minus coupon or coupon minus spread. We've got a difference here of, what have we got? A difference of 0.5%, right? The difference between the spread and, so the spread is 5.5%, and the fair coupon, the fixed coupon, not the fair coupon, the fixed coupon, which is actually paid. Of course, the fair thing to pay would be 5.5, right? So that was a slip of the tongue there. So the difference that we're looking at is 0.5%. That mispricing in terms of spread is going to have a price impact or calculated by scaling up by the effective spread duration. So scale up by 4.5. All right, so the difference, the price impact of the difference is going to be 0.5 times 4.5, which is 2.25%. So I'm ignoring signs for the moment, because difference just means take the big one and subtract the smaller one. Then I use my understanding. Okay, what's being paid is less than what's fair. What's being paid is less than what's fair. So, I'll just reiterate that. The CDS spread is greater than the fixed coupon. In other words, what is being paid is less than what's fair. And so the buyer, the protection buyer, must pay the seller. Okay? The protection buyer must make a payment to the protection seller, because they're not paying enough through the fixed coupon. And similarly, okay, you can say we're going to adjust our percent of par price, essentially, by 2.25%. But we're going to adjust it, and it's important you step away and go, we're going to adjust it up or down. We're going to adjust it down, aren't we? Why? Because the CDS spread is greater than the fixed coupon. It all comes back to that. This is a low quality name. CDS spreads are high relative to what's paid, and therefore this name is going to trade below par. So its price is actually going to be 1 minus 0.0225, or if you like, the price is going to be 100 minus 2.25% in percent terms, all right, which is 97.75%. So hopefully you stayed with the logic there. I always go for the difference and then impose the understanding on which way round we either pay the upfront premium and adjust the price. Okay, you'll see the slides just going through the formulae here. The upfront premium, they look at how much is fair over what's actually paid, and of course if this is positive, then the buyer needs to pay more. That's pretty much what we said. When it comes to pricing it, you could remember if you want, it's fixed coupon minus spread and just an adjustment to 1, but it's really just the same, literally same difference scaled up by the same amount. So it's 2.25%. You can just think, let's push that up if what's being paid is too much because it's a high quality name, or let's push that down, that price down, if what's being paid isn't enough because it's a low quality name, so spreads are high. All right. Oh, and look, the slides are doing the quick approach here. All right. We haven't quite finished yet though. Part 2 asks us to calculate the mark-to-market gain or loss to the protection buyer if spreads immediately fall to 5.4%. Now, gain or loss. Firstly, big picture. Protection buyers win when spreads widen, when things get worse. If spreads have fallen, then that is going to be a loss, not a gain. Okay? And the impact of this loss, we need to think about change in spread and multiply through by spread duration. So the original CDS protection was at a fixed spread, a fair CDS fixed spread. Well, the reason they're using the words fixed spread there is because that's your in price and that doesn't change. So your in price, your fair CDS spread at the initiation was 5.5. This spread falls to 5.4. In other words, it falls by 10 basis points. Okay. You can take those 10 basis points and scale them up by 4.5 and you'll get 45 basis points. And once again, take a step back. 45 basis points not in your favour, it must be a loss. All right. So I think even the slides there are, there's too many negatives going on there, and that number doesn't come out. That's a good lesson in itself, isn't it? That number doesn't come out as negative. So it's clearly the way this has been applied, if you like, the polarity hasn't been preserved. It would be my advice that you understand that the protection buyer wins if spreads widen, the protection buyer loses if spreads narrow. Work out the difference, scale it up by effective spread duration, and you will come out on the right side here. The reason why, by the way, our original formula hasn't worked, the negatives that's tripping everyone up, is that this would really apply to a bond, wouldn't it? Ouch! Spreads are narrowing, so a bond would rise. But of course, the buyer of protection is short credit risk, that's why they're losing. So I think just abandon signs there, that's nasty. You end up having to use understanding and logic, and if you understand that the CDS buyer wins if spreads widen and loses if spreads narrow, then you're going to get the right side of gain or loss, like we did right at the start of that example. Okay, so let's talk a little bit about CDS long-short strategy. We're going to take a CDS long position when we expect spreads to go up. All right, remember the buyer of protection is either hedging, which is not controversial, against things deteriorating, or betting that things will deteriorate. So CDSs are quite controversial because they allow the protection buyer potentially to speculate on conditions worsening on a reference obligation that they don't own. That's controversial, because it's like buying insurance on your neighbour's house. If you bought insurance on your neighbour's house burning down, your neighbour might be slightly curious as to why you're so interested in that. You don't own it, you're not affected by it burning down, so why are you betting that the house burns down? That's the kind of negative view on buying protection, in other words, shorting credit under a CDS contract. Of course, the other side of the argument is that actually, the market will be more efficient if we can short credit names easily. The market will be a lot more efficient. You'd certainly see the fair price for your neighbour's insurance if everybody that could or wanted to buy insurance on their house burning down could. It could be the case that your neighbour has a very elaborate incendiary devices in their house and that other people are kind of making an informed and educated bet that things are going to go wrong. Of course, that's short selling, isn't it? So, the proponents of naked, as it's called, long CDS protection would really just argue that it's reasonable to be able to express your view that things are going to deteriorate for companies who are have bad business models, or companies whose bonds are overpriced, for example. Just bear in mind that CDS short position, that's where we want things to improve. We want spreads to narrow, all right? We want to collect a nice big fat, fair CDS spread when we think about the fixed coupon adjusted for the upfront payment. We want to collect that. We're going to be very happy if things don't deteriorate because we've sold protection, okay? A long-short strategy is where we do both at the same time. Take your time with these CDS strategies because there's lots of moving parts. There's long and short CDS contracts, okay? There's long and short credit risk. There's the payment and receipt of the fixed coupon. There's the upfront payment. All of this stuff you need to tread really, really carefully. And if you tread slowly, what I would refer to as pigeon steps, you won't lose any time because you're likely to be given adequate time for all of this in the exam. Just make sure you don't trip over your own feet here. A manager wishes to increase exposure to XYZ, decrease exposure to ABC in their credit portfolio. Okay. Just the way that's framed, immediately we've got to think carefully about what we're going to do. Both of these have 5-year tenor. That's kind of like the maturity of the CDS. There's the fair CDS spread for each name, and there's the effective spread duration. Interestingly, are we told whether they were high yield? Does it matter whether they're high yield or investment grade? Not so much yet, I don't think. Otherwise, we'd be told it, I think. So describe the appropriate long-short CDS trade. Okay. We want to increase exposure to XYZ. We think XYZ is good. We think XYZ is fine. XYZ is going to be brilliant. Do we need protection on that? No, we don't. We're going to sell protection on XYZ to take on board credit risk and increase exposure there. Okay. We don't like ABC. We want to decrease exposure. It's a bad name. We think things are going to go wrong. Protection-wise, we'll buy protection there, which is essentially shorting the credit risk of ABC. Okay. So that answers question number 1 here. Describe the appropriate long-short CDS trade. We're going to go long a CDS in ABC and buy protection, and we're going to sell a CDS, all right, in XYZ and essentially sell protection. Okay. The next question we are asked here is we're asked to calculate the manager's return if ABC spreads widen by 15 bips and XYZ spreads narrow by 20 bips based on 15 million notional contracts. Now, whenever you're given a question like this, kind of front run it a little bit by thinking, what do I expect to happen? And then your calculations can maybe reinforce that. We are buying protection on ABC and spreads have widened. Profit? You bet. That's a win. We have sold protection on XYZ and spreads have narrowed. That's a win as well. So we're going to win here. We expect to see a big fat profit at the end of all this. We're going to scale our numbers up by 15 million notional principal. But what we need to do is think about what happens when ABC spreads widen by 15 bips. Okay, what we can do is take the 15 bips. There they are there in decimal form. Don't forget to get from bips, basis points to decimals. You divide by 100 squared. So there's 15 divided by 100 squared. Scale it up by the effective spread duration and then apply that to the $15 million notional principal. That's a 103 gain from the long protection on ABC. With XYZ, things improved. You took the right trade there. There was an improvement of 20 bips. We're just ignoring the signs here. I think that's the right thing to do. 20 bips times the effective spread duration of 4.62. Scale that up by notional principal, and that is a gain as well. A gain that you understand is there rather than rely on you remembering double negatives. Double negatives, it's like a return trip. You just end up back where you started. So, you could argue that was minus 15 and that was minus 0.02, but I would wager it's more robust to understand that if you sell protection on XYZ and spreads narrow, you are winning. And so that's going to be a positive number. Add them up, you get a healthy profit of 241,875. Okay, so we're going to make our examples a little bit more in depth now. We're going to start talking about trading a view on the credit spread curve. Now, very much like in the yield curve reading, we kind of break up our views into a static curve, in other words, a curve that we don't think is going to change, but we will roll along as time passes, okay, roll down as the time passes, okay. And we're also going to think about what happens if we've got a dynamic view as well, both in CDS terms and in terms of trading the underlying bonds as well. So first up, static credit curve. This is totally analogous, by the way, to a static yield curve, which we spent so much time getting comfortable with in the last reading. We can plot the credit spreads for a certain class of issuer or even a certain issuer. We can plot those credit spreads versus maturity. It's normally upward sloping. You normally get paid more for longer dated maturities on the basis there's more credit risk, more chance that, of default essentially over longer time frames, or more uncertainty over longer time frames. So a manager who believes the credit spread curve will remain unchanged, what you know is you could say buy a 5-year CDS now, and in 1 year's time, if the curve hasn't changed, you'll be here. Spreads will have fallen, okay, which is good if you're buying protection, okay, but you're not getting any shift in the curve, which is that's your view. There's no delta S of the curve shifting up and down across the whole curve, all right? So there's two ways you can try and profit from this view. You could, let's deal with the second one, this one first. You could increase the spread duration by buying and holding longer dated bonds. So really what you're doing here is you're saying, I'm going to hold longer dated instruments, I'm going to move out and collect higher credit spreads for longer spread durations. This is analogous to really just buying and holding under the yield curve. When you've got an upward sloping curve, you buy longer dated assets that are yielding more. And in this case, you're buying longer dated credit risky assets or selling longer dated CDS contracts because you'll collect a higher credit spread, all right? Or you'll collect a higher premium overall under the CDS because the curve is upward sloping. You might sort of say, well, why doesn't everyone do that? Well, that's because not everyone has the view that the curve remains stable. The risk when you increase spread duration or duration in general, the risk is that rates go up. You don't think that's going to happen. You don't think rates or spreads are going to shift up. Okay, you don't think spreads are going to shift up, and so you're taking the extra spread for longer maturities, which is really including risk premiums for high spread duration as well, like a term structure there, more price risk due to higher spread duration. You're taking that, but you don't think actually the risk is going to crystallize. You don't think spreads are actually going to shift. In fact, if anything, spreads are going to roll down the curve and you're going to benefit even more. Okay, so that's one way of dealing with or trading a static curve. Another way would simply to say that you think things are going to stay the same, and on that basis you're just going to take as much risk as possible, increase the spreads on the portfolio by lowering the average credit rating of your portfolio, or by selling protection in lower credit quality names. Now the idea here is that you're earning a big spread, which if things stay stable, is going to come through with positive excess return. Remember that excess spread that we mentioned in the last reading? The excess spread is the spread that's priced into the security minus, when I say the last reading, I meant a few modules ago actually. So it's the first module of this reading when we came across this. So we got spread minus spread duration times change in spread. All right, that's the price impact of spreads moving, minus your periodic loss due to default, the impact of loss due to default, which is the probability of default times loss given default. Now, if you think the credit curve is going to stay the same, you can collect a spread. That's going to be 0, all right? And this here is predictable and static because it's staying the same. So chances are you're going to earn a spread that's in excess of these two items here, and you're going to outperform. All right. Chances are there's even a bit of a risk premium here for the fact that these things are uncertain. Both these things, if they stay the same, you are going to earn excess return. Okay. So and if you're going to earn an excess return, if you know that, why don't you just maximize the spread over these other components? And that's really what's happening here in method number 1, lowering the average credit rating of the portfolio. So look, for the exam, you just need to take away those two ideas: lower the credit rating of the portfolio, or sell protection on lower credit quality names, high yield names, or just increase spread duration, or The other thing would be to sell protection on longer dated names. They're both to take advantage of a static credit curve view. Now, if you think the curve's going to change, that's where you might think delta S is going to happen, either shift up. If you think things are going to shift up, then bring your spread duration in, because you don't want exposure to that. If you think that delta S is going to shift down, then maybe extend your spread duration, because that increases your exposure to prices rising. Your exposure to spreads falling and your prices will rise more. Another view would be maybe a change in the shape. Maybe you expect an upward sloping CDS curve, or credit spread curve technically, an upward sloping credit spread curve to flatten. Now this is, we can borrow our kind of logic from the last reading here. If we think that longer term spreads are going to fall and shorter term spreads are going to rise, what does that mean? Well, if we were holding bonds, then, and this is a crucial point, if we were holding bonds like in the last reading, we like it when rates go down, so we'd buy those bonds. We're talking about spreads now, but we'd buy credit risky bonds here. Where rates go up, we wouldn't want those bonds. Now you need to turn that into a CDS comment, which is the other way around when you think about trading the actual security or contract. If you like these bonds, you would sell protection on them to take on board their credit risk. If you don't like those bonds, you would buy protection on them. Okay, so slides are agreeing with us here. Buy short-term CDS protection, which wins if spreads increase. You can see that happening explicitly there. Maybe we've gone all the way around the houses. Maybe we should have just said, if spreads are going up, buy CDSs here. If spreads are going down, sell CDSs here. Maybe that would have been an easier route to our destination there. Okay, let's have a look at an example here. Here, it's a static curve example. In other words, we don't expect the curve to change. We've got here a manager looking at a 12-month trade. So that's your trade horizon. And they plan to increase the spread duration. That was one of the ways of essentially expressing your view that the curve's going to remain static. Increase your spread duration. What have we got here? We've got high yield index CDS. All right, with these details, and we've got a longer dated one, which is going to have a higher spread duration. All right, with a higher CDS spread. Now we want to take on board exposure. We want to increase spread duration and take on board exposure. Woe betide anybody that says, well, in that case, let's buy the 10-year CDS, because that is falling into the classic pitfall. Right? If you want to take exposure, all right, increase spread duration, which means increase exposure, fixed income exposure at the 10-year name, you need to sell protection. Okay? I mean, they're being coy here. They're saying take the appropriate position in 50 million notional of the 10-year CDS, assume annual coupon payments and 9-year effective spread duration of 8.1. I guess the first question is, what should we do? Well, obviously, when we're interested in the higher spread duration, the trap here is to say you buy that contract. No, to increase exposure, you would sell that contract, all right, and collect these higher CDS spreads at longer maturities without the risk, without the concern that spreads are going to move against you, all right, because you think the curve's going to be static. All right, so that's the answer to the first question. Should we buy or sell protection in the 10-year name? The answer is we should sell protection in the 10-year name, all right? Sell that, and after 1 year, it will turn into a 9-year CDS spread that, if we're rolling down the curve, an upward sloping curve, which is the default, that these curves are upward sloping, just like yield curves were, we're going to roll down that curve. Spreads are going to, the spread is going to roll down the curve and fall. We're not going to get any shift in spread, all right? There's no delta S that we need to worry about because we've got a static curve, so we would outperform with this strategy, okay? If we do this, what are we going to do? We're going to take a sell protection, $50 million par or notional on the 10-year name. Okay, so let's think about what coupon income we collect there, all right, for this name, for doing that. So that will be on the slide here. The high yield coupon, of course, will be 5%. Don't forget that. That's the standardized coupon that's paid. It's actually paid for a high yield name. Okay, so you're going to collect annually 5% of the par of 50 million, which is 2.5 million. That's going to come in if you sell protection. Okay, the roll down return. Now, what have we got? Because you might remember from earlier modules, they assumed that yield curves were flat earlier, but here we have got 2 points on the CDS curve, haven't we? We've got a 5-year spread and we've got a 10-year spread. So what we're going to do, and I think an exam question would guide you on this actually, they would tell you to do it, but we're going to interpolate between the 10-year and the 5-year to estimate what we think the 9-year CDS spread is going to be once we roll down, and after a year there's only 9 years left on this contract. Now, do you remember how we did interpolation? The way we did it, we said we got a low maturity, in this case tenor, we got a high maturity, and we got a target maturity. Okay, we said that the weight in the lower name, when we're thinking about what weights we should give these 2 CDS spreads that we know, the weight in the lower maturity is going to be the high maturity minus our target divided by the high maturity minus the low one. And in this case, it would be 10 years minus our target of 9 divided by 10 years minus the low maturity of 5. So that's 1 over 5, which is 0.2. So that's the weight we're going to put into this one, the 5-year name, 0.2. All right, not a lot of weight because we're closer to 10 than we are 5, aren't we? We're going to put most of the portfolio, 80%, into this CDS, and that gives us our interpolated CDS spread for 9 years. All right, for the 9-year maturity or 9-year tenor technically, of 450 times 0.2 plus 550 times 0.8. Okay, and that's how we get to 530 bips. Now, as you know, if you've been watching these videos, this is my preferred method of getting to the weight in the lower name, and it does kind of stick, and you can kind of see what it's doing. If that distance is small, we haven't got much in the lower name, have we? You can always go through the algebra of it, which the slide is probably indulging in. Targeting 9 with a weight in 5 and 1 minus that weight in 10 years gets us out to the 0.2 and the 0.8 that we first thought of. Weight your CDS spreads. That must be the 5-year CDS spread. That must be the 10-year CDS spread accordingly, and you come out the number that we got already. Okay, so that's the interpolated CDS spread. What you now need to do is price these contracts and think about the change in price. Price the contract at initiation when there's 10 years to go, and then price the CDS after a year when there's 9 years to go and the CDS spread has changed. So there's a lot to this question actually. There's interpolation and now there's pricing as well. So we will remember that the CDS price is for each dollar of par or notional principal, it's 1 plus however much we are overpaying for the protection. All right, scaled through by effective spread duration. That's one way to think about it. However much the buyer is overpaying for protection, all right, because spreads are actually lower because it's a high quality name. Remember, it's an inverse relationship between spreads and prices. That's the thing that can calibrate your thinking there, all right? So look, we started off, we've always got a fixed coupon of 5%. We started off with a CDS spread of 0.055 and an effective spread duration of 8.9. That was given to us a while back. That was here. That's the original effective spread duration of the 10-year CDS. So we can multiply our difference, take our difference, 0.05 minus 0.055, that's obviously negative 50 bips, scale it up by 8.9, all right? Now that is a negative, okay? What it's really saying, all the logic is there. It's a negative, the spread is wider than what's being paid, so it's a negative, it means the price is going to be below par, and sure enough, it is. It's at 0.955 for every dollar of notional principal. When we get to 9 years, we've already said that the 9-year spread, with no change in the curve, we expect to roll down in terms of CDS spread to 530. So we just replace 530 in there. 530 bips is 0.053 in decimal terms. And, I guess this very strong hint in the question here that we needed to interpolate and reprice the contract was where we were given a 9-year effective spread duration of 8.1. The fact that you're given that suggests you're going to be using it. And this is where you use it. You're working out essentially the upfront payment on the 9-year CDS. Now, to reprice it, just remember the CDS spread is negative, causing the inverse price spread relationship. And what we find here, actually, if the spread is falling to 530 basis points, what we're finding actually is the price is not so far below par. All right, still below par because the fixed coupon is still bigger than, the fixed coupon, apologies, is still smaller than the spread, okay? But when we multiply up here, we get a negative number and we add 1. That's how we get the 0.9757. So it's still below par because what's fair is still higher than what's actually paid, the fixed coupon, all right? Still below par, but less, not as far away from par as what it was. In fact, your price is going up, isn't it? If you're buying at a protection at a price of 0.9555 and selling at 0.9757, then you are making a gain, all right? In fact, we can calculate that gain. Here it is. We'll just cut straight to here. You can calculate that gain. And for every dollar of notional principal, it goes from being worth 0.9555 to 0.9757. Scale that up by your notional principal of 50 million, and that's your gain due to roll down. Okay, just rolling down the existing curve where we interpolated the 9-year spread. Bolt on the coupon, which seems like a long time ago now because it was. All right, bolt on that coupon, and that's your total return from the CDS position. That really is that's really the rolling yield, isn't it? Coupon income plus roll down return. That's really the rolling yield. Those first two components of the 5-step return decomposition that we've seen so many times. Okay, the final thing we're going to do in this reading is trade a dynamic view on the credit curve, which is dynamic. In other words, it's going to change. Now remember, we had a discussion about the credit cycle at the start of credit strategies, but in the end, when you look at the examples that they present to us in the curriculum, you just need to take these key takeaways away. In an economic recovery, things are getting better, so spreads are going to be narrowing, particularly in high yield. So we want to take exposure there, buy those bonds or sell protection on those bonds, okay? And do the opposite with investment grade. The other thing that happens in a recovery is the high yield curve steepens, or if we're anticipating a recovery, we're anticipating the credit curve will steepen. So there's a little bit more to that one. The credit curve is going to steepen like so. Long-term spreads are likely to go up relative to short-term spreads, which are likely to go down. Now, remember, this is spreads, and you can, one of the ways to get around this kind of double negative, which is a plague on credit derivatives in particular, CDSs, is to just think, look, if the spread's going up, we're happy to buy CDSs there, all right? So we'd go long CDS here, long CDSs, in other words, buy protection. And if we use our language from the previous reading with the yield curve, when rates were going up, we didn't want bonds there. We would underweight the bonds, okay? So that's the general idea. If you look at what they're saying about the long-term end of the curve here, sell the bonds, yeah, that's what I mean by that cross, and at the long-term end, buy protection, yeah? And you do the opposite at the other end. Spreads are going down, so we would buy the bonds, we would sell protection there. All right. And yes, vice versa for the slowdown. I'm not a massive fan of, stating things that are contrary to each other because people don't necessarily see the message. But yeah, slow down, spreads widen, and so we need to get out of those high yield names or buy protection on them. Okay. When it comes to an economic slowdown, we'd expect actually the credit curve to flatten, or even invert. So short-term spreads are going up, long-term spreads are going down, okay? And what does that mean? Well, when spreads are going up, we don't want to be in bonds there, but we do want protection, okay? Where spreads are falling, we do want to be in bonds, but we don't want to be in protection. Okay, and they should be backing this up. Sell short-term bonds, that's what that's saying. Buy long-term bonds. Yep, we said that one here, didn't we? The CDS is buy short-term protection. Yep, there's a tick there. Buy short-term protection. Yep. Sell long-term protection. Okay. I prefer to try and visualize it, all right, to decide what you're going to do. And once again, my advice is woe betide anyone that just tries to learn all this stuff without the understanding. That's going to smart and it's not going to be there for you on exam day. Okay, let's put this understanding into action then. We're going to trade a dynamic curve here using bonds. That's what they mean by cash strategy, using the underlying bonds. We've been given 3 bonds here of deteriorating credit quality, increasing spread, increasing expected loss. Expected loss is the probability of default times loss given default. And you've got increasing, you've got effective spread duration here, which varies around a little bit. Maybe the bonds are of different maturity, aren't they? So that would affect duration as well, wouldn't it? Anyway, so we'll take those effective spread durations. The manager is expecting an economic slowdown. All right, that informs what we should do. With an economic slowdown, we expect high yield spreads to widen a lot and investment grade spreads not to widen so much. So do we want to be in high yield names? No, we do not. We're going to sell high yield bonds and we are going to buy, a flight to safety here, we're going to buy investment grade bonds. And this is a 12-month trade. We're going to take a single 100% long position and a single 100% short position. Okay, so this is a flight to quality trade, isn't it, really? We're looking at getting away from high yield names in times when we expect conditions to deteriorate. So that has informed, we've already answered question 1. All right, what we're going to do is sell the lowest rated name. All right, in fact, that's the only high yield name, isn't it? Double B. And we'll buy the A rated bond, all right, the investment grade bond. We'll leave the treble B alone. That's because we're told we're taking a single 100% long position and a single 100% short position. All right. Okay, now calculate, here we go, calculate the excess spread of the portfolio and the benchmark. So there was a benchmark there. The manager's benchmark is equally weighted across the 3 zero coupon bonds. They happen to be zero coupon bonds. Okay, so calculate the excess spread of the portfolio and the benchmark under an economic slowdown. Now, this is actually quite fiddly. When you buy the bonds, you lock in the original OAS, but we're now expecting the OAS to increase. That's what happens when we move into the slowdown. They're going to increase by 40% for investment grade names and 80% for high yield bond names. Right, that's what the delta S is going to be. All right. So changing spread is going to be 40% for investment grade names and 80% for high yield bonds. That's proportional, not percentage points. We don't expect the spreads to go up by that amount. We expect them proportionately to increase by 0.4 and 0.8. And notice this as well. This is a new thing. Expected loss increases as well. So, we are essentially saying that our expected losses evolve to be higher than what we previously expected before the slowdown. So our losses, our credit default losses, if you like, what was PD times LGD, that evolved to be higher than we previously expected. That's the way I read it anyway. 40% higher for IG and 80% higher for high yield bonds. So do you remember our formula? It's a good time for us to revise our excess spread formula. Excess spread is the spread you're bringing in. That's the original spread that you bought the bond on. That's what you'll learn. When we think about the impact of changes in spread, remember we were told that the changes in spread were 40% for IG and 80% for high yield. And by the way, this sets your expected loss. This whole thing in the brackets here turns out to be 40% higher than expected under our investment grade and 80% higher than expected under high yield. All right, everything in those brackets. So let's do bond A, and maybe the other bonds will fall out. We don't need to do triple B. We're not trading it. Let's do bond A and bond double B, and then triple B you can look at for your own delectation. So 1.3 should be the original spread of bond A. There it is. If in doubt, decimals in, decimals out, folks. Okay. Then we're going to take off, that should be the effective spread duration of bond A. There it is, 6. And then, yeah, the change in spread is 40% of the original spread. Okay. And it's going up. So that's bad news. So that's just a different way of stating, what the change in spread is expected to be. We're also going to take off what was our original expected loss. So that's the decimalized version of our original expected loss. There it is, 0.09. To turn it into a decimal, that's a percent. So turn it into a decimal, divide by 100. That's how you get 0.0009. And this is representing the fact that our expected losses turn out to be 40% higher than expected. Okay. That's what that 1.4 is. When we do the double B bond down here, that must be the original spread. I'm not going to keep jumping around here. I'm just going to look back. Yes, it is. That must be its effective spread duration. Yes, it is. And look, the spread is expected to move by 80%. Okay, that's the original spread. And we're going to subtract the original expected loss, 79 basis points, scaled up by a factor of another 80%. So that 1.8 is representing the fact that the original expected loss turns out to be 80% higher than expected. Okay. So what have you done here? You've bought this and you've sold that. So put those two together and you've made a healthy profit, right? Oh yeah, we do need to know the expected, that's a good point. We do need to know the expected spread for the middle bond for the benchmark. Okay, so there it is. I'll let you put the numbers together for that. That, of course, there, triple B is an investment grade bond. That's why we expect a 40% change in spread and a 40% increase in expected loss. Okay. So putting these together, just averaging those gives you what you expect for the excess spread for the benchmark, because the benchmark was equally weighted. All right. So minus 5.47. Your active trade, I was thinking about the portfolio when I said we're only interested in the A bond and the double B bond. We're going to go long A, 100%, and that does lose a little bit in excess spread, but we short the double B bond, which has got that massively negative excess spread, and we earn that because we've shorted that bond. That's a positive to us. So our total excess spread is 9.15, okay, for this trade. And yes, you could argue that the value added of the decision, the active return of this manager, is the difference between 9.15 and negative 5.47. So 15% active return from this manager versus the benchmark. Okay, that completes module 5 of the credit strategies reading in fixed income. Very important module, as we said right at the start. Make sure you can do all the calculations that we covered there, and make sure you're good with your CDS language. The upfront payment, the pricing, and calculating the returns from a trade.